Okay, excuse me. As we go through this, you guys should be taking notes as well. So today we're going to look at predicting outputs. Up until now, we have been studying the relationship between input and output values. But what happens when our relationship gives unpredictable results? In other words, what happens when you cannot predict the output for a given input? Today, we're going to look at that situation and you'll be introduced to the quality that makes a relationship a function. So, we've been using that word, but we haven't actually defined it yet. Today will be that day. All right, our first problem talks about the cola machine. So the cola machine at the school offers several types of soda. There are two buttons for your favorite drink, Blast, while the other drinks, Slurp, Lemon Twister, Diet Slurp, each have one button. Describe the input and output of this soda machine. So I want you to think about that for a minute, see what you can come up with, type your answer in, and then we'll talk about what it is. So your inputs could be money, could also be the buttons that you push. And your output is going to be possible soda or different types of soda, we'll say. Okay. So while buying a soda, Miss Whitney pushed the button for lemon twister and got a can of lemon twister. Later, she went back to the same machine, but this time pushing the lemon twister button got her a can of Blast. Is this machine functioning consistently? Why or why not? So again, take a second, type in your answer, and then we'll see what you got. So hopefully you would say it's not functioning consistently. Um, Imagine if you went to the soda machines in the lobby and you pressed the button for a Coke, but it gave you a Sprite. You know, you'd not be getting what you were expecting to get. So we would say no, it's not functioning consistently, and the reason is because you can't predict what you will get when you push the lemon twister button. All right. When Brandy pushed the top button for Blast, she received a can of Blast. Her friend Miguel decided to be different and pushed the second button for Blast. He too received a can of Blast. Is the machine functioning consistently? Again, why or why not? So take a second, answer that question, and then we'll come back and talk about it together. So this time, we could say yes. Um, you can make a pretty good prediction. So you can predict that every time you press a blast button, the output will be a can of blast. So as far as we are looking at it right now from the perspective of trying to get a can of blast, it's functioning in a way that we can predict. Okay, when Lutfi pushed a button for Slurp, he received a can of lemon twister. Later, Taisha also pushed the Slurp button and received a can of lemon twister. Still later, Taisha noticed that everyone else who pushed the Slurp button received a lemon twister. Is the machine functioning consistently? Explain why or why not. So again, take a second, answer this question, and then we'll come back and talk about it. Notice the question is not, is it functioning correctly? It's functioning consistently is what we're trying to decide. So again, we could say yes. It just so happens that when you push the slurp button, you will get a can of lemon twister. Now, that could just mean that when they loaded the machine, they just put the lemon twister in the wrong part of the machine. Okay, let's try the next question here. So functions. In a relationship like the soda machine, we want the outcome to be consistent and predictable. And that's some key words here. We want those outcomes to be consistent and predictable. When it was, we said that the machine is functioning properly. We're going to look at each of the tables and graphs on the next couple pages that show different inputs and their outputs. Decide if the graph or table could be describing a soda machine that is functioning properly. So what we're looking for is consistent results. So if we give an input one time and get a specific output, but then we use that same input later and get a different output, that is not functioning consistently or functioning properly. Okay, so let's look at some of these. All right, in our first table, so we have button number 1, results when we press it the first time in a sticks candy. When we press button 1 again, we get sticks again. When we press button 2, we get M&Ns. But here when we press button 2, we get a different output. So the key is looking for that relationship between the input resulting in the same output. So both times we pressed button 1, we got sticks. But we pressed button 2 and got 2 different outputs. Okay, so it doesn't matter, when we press a different button that we get the same output. Like, that's okay. But when we press the same button and get different outputs, that means our machine is not functioning consistently. We want it to be able to be consistent and predictable. So for this first one, we would say it is, no, it is not functioning properly. Since button 2 gives 2 different outputs. And I'll just put in parentheses here what those 2 different outputs are. Okay, let's look at the next one. So I'm going to just kind of scan through my tables, look at my button. That's what this is here. Okay, these are going to give my outputs. So my buttons are what we call the X's. So let's see if we have any repeats of our buttons. So it looks like I just have one button 7, no other button 7s. And it gives me an output of 6. Here I have one button 2. I don't see any other button 2s. And it gives me an output of -3. Here I have my input, or my button is 0. There's no other button 0s. It results in my output of 4. And I'm just going to kind of keep going through this. One button 4, resulting in an output of 2. We see one button 9, resulting in an output of 10. And then let's see, we see one button -3, resulting in an output of -3. And then last but not least, we've got one button 6, resulting in an output of 0. So as we look through that table, I could make a prediction that later, if I again pressed button 7, my output should be what? What do you think my output would be? Take a second, type it in the video. Yes, our output should be 6. It's predictable. If I pressed button -3, what do you think the output should be? Good. Again, -3. It's predictable and consistent. So is our machine functioning properly? We could say yes. We can make a prediction. Based on the table. Okay, so let's try this next one. So I'm going to start kind of slowly thinking about these as inputs and outputs. So let's look at each of our inputs and see if it's a consistent type of behavior. So as I look at this, I see that we have only one button 3 the entire time we have this table in action, and it results in 4 as our output. Okay, let's see. Our next number in our table is -1. I only see one input of -1, and it results in an output of -5. Next up, I have an input of 2. Now, as I scan my table, I see another input of 2. In order for this machine to be functioning properly, we have to get the same output every time we press that input of 2. Well, here we have an input of 9. But when I press the button 2 again, I get a different output. So since these are different, that tells us that our machine is not functioning properly. So as we're going to summarize here, we would say no, since 2 as an input results in 2 different outputs. We'll just put in parentheses here 9 and -8. All right, let's try a few more. So this relationship that we've been saying between the outputs and inputs, it's called a function, which is a special type of relationship. Only if the inputs and outputs behave like a properly functioning soda machine. In other words, we can make predictions and we are seeing consistent behavior. So let's think about what it means for a relationship between inputs and outputs to be a function. And there's lots of ways that we can look at this. So we've looked at tables. We haven't taken a look at what that appears on a graph. So we're going to look at tables and graphs, remembering that every time we have a specific input, which we've been calling our x's, we should get the same output for that one input. If we get two different outputs for that same input, then it's not behaving like a function. So let's take a look at each of these individually here. All right, so for the first one, it is a graph. So what I'm looking for here is a place where my input results in 2 completely different outputs. So since my inputs are x values, what I'm looking for is where along that line, and I guess I could do that with a highlighter, maybe make it a little bit easier to see. Look along that x line and see if you have any more outputs along that line. So if we're on -3, that's my x value. There's no place else that I get an output for -3 except right here. That's my only place that I have an input of -3 and then I'm given an output. Okay, my output is just 1. Okay, let's try some of these other inputs and outputs. So now I've got an input of -2. The only place where I get an output when my input is -2 is right here. And I'm just going to kind of continue that process. So the next one we have is an input of -1. The only place where I have an output of -1, an output when my input is -1 is at that 1 point. And let's just continue to roll through this graph. So when my input is 1, there's only one place where I get an output. when my input is 2, there's only one place I get an output. And finally, when my input is, 3? Use a different color for that. Okay, maybe we won't use a different color. It does not like me right now. It doesn't want to go to a different color, so we'll just use purple. When my input is 3, there's only one place where I have an output. So because we can predict what's going to happen every time we use a new input, we can say that this is a function. This is behaving like a function. So yes, it is a function. Since each input has only one output. All right, let's try some of these other ones. Okay, so let's just pick an input, right? Doesn't matter which one we pick at this point. I'm going to pick, let's say, an input of 1. So I'm going to do the same thing we did in the other picture. Now this time when I have an input of 1, look at all of the places that I get an output. Now an output just means that there's a place on my graph that has that x value. There are 3 different outputs for that one input. And let's try another one here. So if I were to pick another input, let's say x equals 0. Let's look at all the different outputs we get when x equals 0. Here's a place on the graph when x equals 0. Here's a place. Here's a place. Here's a place. We have 4 different outputs for that one input. So because it's not consistent, it's not behaving consistently, we can't easily predict. We would say that this is not a function. And the reason we say it's not a function is since there is more than one output for the input, we'll say, just pick one of them, x equals 1. All right, let's try the table now. So I'll just go through and kind of do what we did the last time we looked at these. So I see -8 here. -8 results in an output of 11. So if -8 shows up anywhere else in this table, which it does, in order for it to be a function, it has to result in an output of 11, which we see happening. Let's take a look at our other inputs. Here we have an input of 4. There's no other inputs of 4 except for this one. It gives us an output of 3. Here we have an input of 11. It results in an output of -8. It's the only input of of 11. Here we have an input of 6, and it results in an output of 3. So each of our inputs behaves in a way that is predictable. Therefore, this is also a function. So yes, it is a function. Since each input has only one output. All right, and last but not least, we can do the same thing we did before. Now there's a way that we can do this, and it's called a vertical line test. When you have a graph, you can actually use this thing called a vertical line test to determine whether or not your graph is a function. So let's imagine I draw this vertical line. Okay, so here I have this vertical line. Now let's imagine just that I move this vertical line. As it moves through my coordinate plane, as long as this is all representing, like right now, I'm representing the input of -2, and I see exactly one output. If I move it again someplace else, maybe here, now we're seeing an input of -1, there's exactly one output. If I can move this vertical line anywhere on my graph and there's only ever one output, then it's a function. So I don't have to sit here and test every single input. I can use this vertical line test as a quick way to determine whether or not it will behave like a function. So because no matter where I move that vertical line, I only ever have one input on my function, we can say, yes, it is a function. And we'll even use that as a reason to kind of explain why. We can say, yes, it is a function since we'll say it passes what we'll call the vertical line test. Okay, and that's just taking, you can use your pencil or your pen and just use it like a vertical line and kind of move it over your function and see if anywhere you get multiple outputs. I could do the same thing on these graphs as well, right? I could take one of these vertical lines that I drew and I can move it around, well, maybe around my function, and I can see there's a bunch of places where it intersects more than once, where it's creating more than one output. And you only need to have that happen one time in order to say it's not a function. Okay, next one. All right, so Jade noticed that the line graphed at the right is a function. Hey, I think all lines are functions, she exclaimed. Is she correct? So, lines, we have to be really careful with this. Okay, a line is a figure that looks like what we see on that graph, right? It's not something that looks like this, right? That is not a line. Okay, that is a curve. So if I'm asking you to determine whether a line will always be a function, that's what we have to keep in mind. It has to be um, like the edge of a ruler. So could all lines be functions? I want you to think about that for a minute. Type your answer in, and let's see what you come up with. So maybe you said yes. Okay, maybe you're thinking, I can draw any line on this picture. I can draw this line, I can draw this line, I can draw this line, I can draw, many different lines. But what if I draw a line that looks like this? Let me get a new coordinate plane here. What if I draw a vertical line? So and we'll just make sure we fully draw our axes here. So this is my y-axis, this is my x-axis. What if I draw that green line? It's a vertical line. Is that going to be a function? Well, let's just think about this for a minute. In order for it to be a function, we have to be able to determine what the output will be for any given input. Meaning, if I tell you that, this is at x equals 4. Can't quite get that to look right. We'll say x equals 3. So let's say this is at x equals 3. In order for it to be a function, there has to be exactly one output when we use our input as x equals 3. But the problem is I've got all of these outputs. There's an infinite number of them. These are all different outputs that we get when x equals 3. So this is actually not a function. So the only type of lines, so vertical lines, are not functions. Since the input has many outputs. All right, now any other type of line will actually be a function. So all those lines I drew over to the right, those will be functions, but that vertical line can't be a function. Okay, last problem. So we're going to do what are called learning logs, and I'm not sure if you did these in your other CPM courses. I'm assuming probably you did. But here's what a learning log is. So throughout the course, you're going to be asked to reflect about your understanding of mathematical concepts in what we'll call a learning log. And we'll have, this will just be part of what I check when I'm looking at your binders. So writing about your understanding will help you consolidate ideas, develop new ways to describe mathematical ideas, recognize gaps in your own understanding. It's important to write each entry in your own words so that you can use them later as a resource to help study or use on a homework. I'm going to tell you where to write those. Remember to label them. We'll just write it in the space that you have underneath this slide in your notes. So it should say today's date, which is 8:30. So just put 8:30:22 at the top of your page. And let's just talk about what it means for a relationship to be a function. So what you are going to do is describe what it means for a relationship to be a function. Um, you can describe this in terms of machines. You can describe it in terms of inputs and outputs, in terms of graphs, in terms of tables. I don't really care. This is for you. But I do want you to spend the next few minutes writing this learning log. I would, as a goal, I want you to have at least, let's say, 4 ways that you can tell if something is a function. Okay, so that's what you're going to put in your learning log. So you should have 4 ideas here. How can you tell if a relationship is a function? Okay, when you're finished, I think the sub has instructions to have you just put your heads down until the bell rings. You can just take a nap if you'd like. You do have homework tonight. It'll be up on GoFormative for you at the end of the period. And I will see you tomorrow. Have a good day.